Okay, hi guys. So I would like to discuss about soalan tutorial dengan kamu ya. I know that I have given you this tutorial question, so I hope that you all dah cuba buat. Alright, so if you look at soalan satu, dia suruh kamu write the differential rate equation for the following reactions. You kena ingat, differential rate equation tak sama dengan rate law equation. And kalau differential rate equation, dia akan ambil kira pasal produk and also dia akan ambil kira pasal stoichiometric coefficient ya. And if you look at here, you can see that soalan nombor 1, 2, 3 ni shouldn't be a problem if you dah tahu macam mana write the differential rate equation. Di mana kalau let's say sesuatu equation tu dia berada di bahagian reactant, it should be rate of disappearance. Okay, kalau di bahagian product, it's going to be rate of formation. So that's why kalau bahagian reactant ada negative sign, kalau bahagian product is going to be positive sign. And then kalau ada stoichiometric coefficient, macam soalan nombor 2 dengan 3 ni, you just buat je satu bahagikan dengan stoichiometric coefficient. Okay, and don't forget untuk letak bracket tajam ni menandakan concentration untuk each of the species here. Alright, since that all of this aqueous and gas phase, so tak ada masalah lah untuk you buat concentration. Kalau let's say another thing, kalau let's say phase dia solid, you tak payah tulis pun lah. Okay, sebab kalau concentration ni only applicable untuk phase aqueous dengan gas saja. Alright, so next ialah if you look at this reaction, di mana you have this kind of chemical equation and dia bagi tahu rate of disappearance of oxygen ialah 0.02 molar per second. Okay, so kat sini you tengoklah dia cakap rate of disappearance of oxygen. Bermaksud kalau you buat rate of disappearance of oxygen is going to be negative. Okay, negative tu kena wajib ada kat depan. Negative rate of oxygen berapa? Rate di concentration of oxygen over dt. Okay, because this whole thing di concentration of oxygen over dt ni ialah rate. Minus ni maksudnya disappearance. So in total, this is rate of disappearance of oxygen, which is equals to 0.020 molar per second. Okay, and then next ialah dia suruh kamu determine the rate of formation of H2o. Okay, soalan suruh kamu cari rate of formation of H2o. Again, kalau rate of formation of H2O is gonna be positive, okay, the concentration of H2O over dt. Dia suruh kamu cari ni. Okay, so macam mana kamu nak cari? First of all, you look at this you look at this equation. So you build dia punya differential rate equation. So how are you gonna build this differential rate equation? It's gonna be this whole thing. It's gonna be negative 1/4 rate of disappearance of NH3, okay, and equals to negative 1/5 is equals to positive 1/4. You write dulu dia punya differential rate equation, baru you tahu nak buat macam mana. Okay, n equals to positive rate of formation of H2O 1/6. Okay, and if you look at this question, dia nak suruh you cari rate of formation of H2O. Dia bagi information rate of disappearance of oxygen. So sekarang ni apa yang you boleh buat ialah you boleh compare between these two. Okay, so bila you compare between these two, You tahulah apa tu, negative 1/5 the concentration of oxygen over dt is equals to positive 1/6 the concentration of H2O over dt. Okay, sekarang ni kita nak jadikan positive the concentration of H2O over dt as a subject. So how? If you want to make it as a subject, you kena bawa lah 6 ni bawa ke sebelah. Okay, so bila dia bawa ke sebelah, so it's gonna be negative 6/5 the concentration of oxygen over dt equals to the concentration of H2O over dt. Okay, and now kan dia bagi information rate of disappearance of oxygen. Jangan risau. So sekarang ni negative this whole thing, the concentration of oxygen over dt ni adalah equals to 0.020 molar per second. Okay, tak habis lagi. Sorry, tak habis lagi. Okay, and then next, what's next? So sekarang ni you buat je lah 6/5 you kalikan dengan 0.02 sebab telah kat sini 6/5 kalikan terus dengan 0.02. Mana negatif tu hilang sebab negatif ni termasuk di dalam definition rate of disappearance of oxygen. So negatif ni termasuk dalam definition rate of disappearance of oxygen, that's why you tak perlu letak negatif kat depan pun, that's why negatif dia hilang, faham tak? So you terus kalikan saja dengan 0.02 and now you will get the rate of formation of H2O will be 0.024 molar per second. Unit jangan lupa ya, please. Unit jangan lupa. Macam mana you tahu unit dia molar per second? Because dia akan ikut unit of rate of disappearance of oxygen yang diberi ni, okay? Alright, and then next ialah rate of disappearance of Nh3. Okay, kalau rate of disappearance of Nh3, you comparekanlah Nh3 ni dengan oksigen. Kenapa you kena compare dengan oksigen? Because you hanya tahu rate of disappearance of oxygen je, soalan bagi ni saja. So that's why you need to compare between these two. So therefore, you tahulah negative 1/4 the concentration of Nh3 over dt, okay, equals to negative 1/5 the concentration of oxygen over dt. Now we want to make this as the subject, okay. So kiranya 1/4 ni you kena bawa ke sini lah. So it's gonna be negative, kenapa negative dNH3 over dt? Because soalan nak kamu cari the rate of disappearance of NH3 kan? And then equals to 4/5, okay, negative 4/5 the concentration of oxygen over dt. As usual, you tahu negative the concentration of oxygen over dt ni adalah 0.02 molar per second. So you buatlah 4/5 kalikan sahaja terus dengan 0.02 and now you will get the rate of disappearance of NH3. I'm sorry, you must put minus in here because maksud rate of disappearance tu kena ada negatif. So it's gonna be 0.016 molar per second. Okay. Alright, so next let's go through this question. Okay, this question Miss dah sentuh dalam kamu punya lecture notes dalam lecture hari tu. Okay, di mana Miss hanya tukar je. Miss buat time tu between oxygen dengan NO, tak silap Miss. Tapi value dia sama je semua. So sekarang ni dia kata dia suruh kamu cari order with respect to each reactants. Bila cakap pasal order je, okay, bila soalan tu cakap pasal order respect to each reactants pula tu, and then dia bagi kamu this experimental data, you cepat-cepat kena fikir pasal order of reaction. And then bila you tahu pasal nak cari order of reaction, you kena fikir pasal rate law equation. Okay, so kalau rate law equation, actually they don't care about the product and also they don't care about the stoichiometric coefficient. So please, first thing first ialah build a rate law equation. Okay, build rate law equation for this chemical reaction. Okay, so you tahu reactant you ada dua, which is H2O8 2- dan juga I-. So it's gonna be rate, okay, is equals to rate constant K kalikan dengan concentration of reactant H2O8 to the power of X, and then kalikan concentration of I- to the power of Y. As what Miss dah bagi tahu dalam lecture, Miss cakap kamu kena compare dua eksperimen yang di mana one of the concentration of reactants tu constant, one of the concentration of reactant tu akan berubah. Okay, so in this case you just cancel out je, and then you akan dapat YU is equals to 1. You tahu Y ni ialah order of reaction with respect to I-, kan? So you dah tahulah order of reaction with respect to I- berapa, and this one you comparekan eksperimen 3 dengan 2 because you nak cari order of reaction with respect to S2O8 which is you will get 1 as well. Next ialah determine the rate constant. Nak determine the rate constant, once you dah tahu you punya X dengan Y, so you just masukkan saja. Okay, so sekarang ni you build the new rate lah, since that you dah tahu rate law equation. Bila you dah tahu X dengan Y tu, so you tahu rate is equals to K concentration of S2O8 to the power of 1 and concentration of I- to the power of Y. Okay, to the power of Y pula, to the power of 1. Okay, and then next ialah bila you dah tahu dia punya X dengan Y, you substitute je eksperimen 3 ke eksperimen 2 ataupun eksperimen 1, mana-mana eksperimen tu punya data, so that you can find the K. Okay, so bila you nak cari K ni, you tahu unit of your rate dibagi initial rate ni, initial rate ni ialah molar per second, kan? Mana molar per second. Lepas tu concentration of S2O8 dengan I- masing-masing M besar. Okay, so kat sini macam mana you nak tahu nilai rate constant you, dia punya unit dia apa, nilai dia you buat bahagi je lah 2.2 kali 10 cos negative 4 bagi dengan the multiplication of 0.16 dengan 0.017. Tapi unit dia, okay, since you tahu yang this one molar per second, so it's like molar per second kena bahagikan dengan M squared. So you, sorry. So you potong one of the M here, so you know that you will get per second per molar. So it's gonna be per second per molar. Okay, so kalau you tengok dekat table yang Miss bagi unit untuk zero order, first order dengan second order tu, you tahulah yang this is actually is a second order punya reaction because the unit of the rate constant dia ialah per molar per second. Okay, macam mana you tahu dia second order reaction? Lagi satu ialah by campurkan dua-dua ni, because if you want to find the overall order of reaction, X campurkan dengan Y, which is in this case 1 campur dengan 1 is equals to second order reaction. Okay, so that's why tally lah dengan this one. Okay, and then next ialah write the rate equation, you just write back sahaja. Kalau you ataupun kalau you nak masukkan sekali you punya rate constant pun boleh juga. So it's gonna be rate equals to 0.08088 per molar per second concentration of H2O 2 minus and concentration of I minus. Okay. Alright, so soalan nombor 4, ni Miss dah bagi tahu dah dekat kamu punya lecture. So I hope that you know apa yang Miss terangkan lah. Miss dah terangkan sebiji-sebiji ni dekat lecture. Okay, so I'm not gonna go through this again. And then soalan nombor 5, okay, soalan ni dia bagi tahu iodine atoms combine to form molecular iodine in the gas phase. Okay, so the rate constant for the above fraction ialah per molar per second. Kat sini dia bagi tahu rate constant punya unit dia per molar per second. So kat sini you boleh agak tak yang ni first order ke, second order ke, zero order. So tengok balik kat table tu. So if you tengok balik kat table, you akan tahu unit per molar per second ni ialah milik this one ialah milik second order. Okay, sebab tu Miss bagi tahu one of the methods untuk you tahu order of fraction ialah tengok dekat unit rate constant dia. Okay, lepas tu dia bagi tahu if the initial concentration of iodine atoms adalah 0.086 molar, calculate the concentration final after 2 minit. Okay, so since sekarang ni, since you dah tahu unit rate constant dia per molar per second, which is this is the second order. So terus keluarkan integrated rate law equation for second order. This is the integrated rate law equation for second order, di mana 1 over concentration of A is equals to 1 over concentration of A initial plus KT. A ni apa? A ni adalah reactant, tapi reactant you siapa in this case? Reactant you ialah iodine. So you buat je, let A is equals to iodine. Okay. So bila you dah buat let A is equals to iodine, tak perlu susah-susah you nak masukkan A, you tu adalah iodine. Okay. So you boleh terus guna this general punya equation. Tapi kalau you tak buat let A is equals to I, you wajib kena letak reactant you dekat A ni. Okay. Wajib. Macam apa macam this one, Miss dah buat let A is equal to cyclopropanone. So Miss tak perlu susah-susah nak tulis cyclopropanone every time here. Macam this one, kalau you tak letak let A is equals to I, wajib untuk you letak reactant you dekat dalam kurungan ni. Okay, tapi kalau you dah letak let A is equals to I, you boleh terus guna je lah 1 over concentration A final. This is something that you want to find, equals to 1 over concentration initial of your iodine yang diberi ialah 0.086. Okay, and then campurkan dengan K. K kamu unit dia per molar per second. Tapi you tengok dekat time ni, dia bagi in 2 minit. Tapi unit rate constant you ialah per molar per second. Unit time dia ialah in second. So what do you need to do ialah you need to convert unit minit ni kepada second. Alright. So sekarang ni you tahu unit of your apa tu? Oh ni dah fix ya. Okay, tak apa, tak nak kacau. Okay, so sekarang ni you tahu unit of your apa tu? Rate constant ni ialah per molar per second. And then you dah convert ni into second already. So second akan tolak dengan second, which will leave yang ni per molar, and then this one is molar. Okay lah, but whatever it is, dia nak concentration you kan, concentration of iodine kan. Okay, you tahu unit untuk concentration adalah M besar. Okay, unit untuk concentration ialah M besar. So bila you dapat jawapan iodine yang final ni is 1.2 kalikan dengan 10 kuasa negatif 12. You kena letak unit apa, bila kalau you tak tahu sekalipun unit dia apa, kalau you tak able untuk cancel everything, you kena recall je unit untuk concentration ialah M besar. Okay. Alright, so next ialah soalan suruh kamu calculate the half-life of iodine atoms kalau initial concentration dia 0.42 and 0.6. So sekarang ni, since you dah tahu this is a second order reaction, kan? So kalau second order reaction, you akan tahu half-life dia punya equation ialah T half is equals to 1 over, supposedly lah, T half is equals to 1 over K concentration of your reactant initial. Tapi kita tadi dah cakap let A concentration of A is equals to concentration of I, kan? Tapi kalau you tak letak let ni, you kena masukkan lah I. So sama je lah kat sini. K dia is something yang you dah you know, dah dibagi dah. And then I ni, I initial ni tengoklah kalau 0.42 masuk 0.42 and then you akan dapat half-life you dalam unit second. Okay, kenapa unit second? Because your unit untuk rate constant ialah per molar per second. Okay, and then this one pula unit dia ialah molar. So ni tolak dengan ni and then per second bawa ni atas jadi second. Alright, and then next ialah what if your half-life tu, kalau let's say you punya initial concentration you 0.6, so masukkan sahaja. Rate constant dia still sama, tak berubah. And you will get the half-life ialah 2.4 times 10 to the power of negative 10 second. Okay. And next ialah soalan nombor 6. Dia bagi tahu the decomposition of dinitrogen pentoxide with rate constant of 5.1 times 10 to the power of negative 4 per second at 45 degrees Celsius is given below. Okay, so soalan suruh kamu calculate the concentration of N2O5 after 3.2 minutes if the initial concentration is 0.25 molar. Alright, kat sini pun dia tak bagi tahu direct kamu punya order of fraction, tapi you boleh tahu the order of fraction if you look at the unit dia per time. Kalau unit per time, you should know already that kalau rate constant to unit dia per time, it is a first order reaction. Okay, so bila soalan suruh kamu cari final concentration of your N2O5, okay, after 3.2 minutes, okay, if the initial concentration given ialah 0.25, so you terus buat, terus bagi tahu integrated rate law equation for first order reaction, okay, which is berapa? Natural log concentration of your reactant initial minuskan dengan natural log concentration of your reactant final equals to KT. Kat sini dia dah bagi tahu siap-siap dah. Let concentration of A is equals to concentration of reactant N2O5. Ingat kalau pasal order of fraction, kita memang tak ambil kira stoichiometric coefficient and kita ambil kira product. Okay, so sekarang ni bila you dah buat let A, so you boleh gunakan saja A ni. Tak perlu nak gantikan dengan N2O5 every time, okay. So you masukkan saja concentration initial of N2O5 ialah 0.25 and this is something that you need to find. And okay, dia bagi tahu time ni in minute. Tapi if you look at dia punya rate constant, time dibagi per second. So, apa yang you kena buat, you kena convert into second, okay. Sebab since that dia punya rate constant in per second, so you need to convert this 3.2 minute in second. So you kalikan je lah dengan 60. And after that, you akan jumpa lah concentration of N2O5 after 3.2 minutes ialah sebanyak 0.227 molar. Unit jangan lupa. Unit concentration, unit dia apa? M besar. Okay. And next ialah KB. If the initial concentration of N2O5 ialah 0.35 molar, dia suruh kamu calculate the time needed for the reaction to be reduced by 0.08 molar. Okay. And by 62%. Okay, kalau kat sini, since that you dah bagi tahu awal tadi kan, that concentration of A is equals to concentration of N2O5. So you boleh guna terus this general equation integrated rate law for first order reaction, okay? Di mana kat sini yang nombor 1 ni concentration initial ialah 0.35 molar, okay? And then concentration yang final ialah 0.08 molar. Okay, and then time taken is something that you want to find, and since that you punya rate constant dia still the same, okay, regardless dia berubah concentration, okay, rate constant will be the same. Alright, so you masukkan saja nilai-nilai tersebut and you will get your time ialah 2893.92 second ataupun 48.23 minutes. Kalau you nak buat in second pun boleh, in minute pun boleh. Kalau soalan tak spesifikkan, your first answer should be in second lah sebab you dah convert into second kan. Lepas tu yang ni kalau you nak buat extra kerja, ikut you lah ya. Okay, again next ialah you tengok ni, kalau dia bagi in percentage, so you need to assume the initial concentration ialah 100. Okay, you need to assume that initial concentration of N2O5 ni 100 molar. Okay, and then the final concentration is gonna be 100 minuskan dengan 6:2, which you will get 38 molar. Okay, so sekarang ni based on the general equation for integrated rate law equation untuk first order reaction, you just masukkan saja all the information and you will get the unit ialah in second. Okay, minute ni extra kerja lah, you nak buat in minute suka hati lah, tapi soalan tak minta kan, so supposedly dia in second je lah. Okay, next ialah soalan nombor 7. A catalytic reaction of ammonia gas decomposes into nitrogen gas and hydrogen gas with a platinum catalyst is one example of zero order reaction. Kat sini dia dah bagi tahu siap-siap dah. Zero order reaction. Okay, and then in one reaction, the initial concentration ialah 1.5 molar and after 120 second, concentration final dia ialah 0.75 molar. Calculate the rate constant. So untuk calculate the rate constant, you kena ingat integrated rate law equation for zero order. So what is it? It's gonna be concentration of your reactant is equal to concentration of your reactant final minus KT. Okay, so kalau let's say you tak buat let, you kena masukkan macam ni. Kalau you buat let concentration of A ni is equals to ammonia. Ammonia ialah, memanglah soalan tak bagi tahu NH3, tapi you should know lah ammonia ni something yang you dah selalu jumpa dah dalam chemistry dari high school lagi. So ammonia ialah NH3. Okay, so bila you dah buat let A is equals to NH3, you boleh terus guna concentration A yang final tu dia bagi 0.75. Okay, and then concentration initial dia bagi 1.5 equals to K, minuskan dengan K, minuskan dengan K. K tu something yang you kena cari. Okay, soalan pun minta kan, time dia bagi 120 second. Okay, so ni unit M, ni unit M. Okay, so sekarang ni bila you dapat K, is gonna be unit dia molar per second. Okay, sebab this is unit untuk zero order reaction. molar per time. Okay, kali ni unit of your rate constant akan ikut unit time. Dibagi time tu in second, so it's going to be molar per second. Okay. Alright, so next, half-life. Soalan suruh kamu cari half-life. Half-life, since soalan bagi zero order, okay, so you kena hafal zero order reaction untuk half-life, which is T half is equals to concentration of your reactant initial bahagikan dengan 2K. Tapi kalau you dah buat, let concentration A, reactant A tu you gantikan dengan, sebab kita dah guna ammonia, so you gantikan dengan ammonia. So you tak perlu buat masukkan ammonia ni, you boleh terus guna this one. Okay, terus masukkan saja nilai initial concentration of your ammonia. Berapa nilai initial dia? 1.5. So masukkan je terus 1.5 divide by 2 kalikan dengan rate constant. Rate constant ni yang you dah jumpa dah ni, yang you dah kira. So masukkan saja and you will get the half-life in unit second, which is sebanyak 120. Okay, next ialah dia kata if the original concentration is reduced to 1 molar, does the half-life decrease, increase or stay the same? And if the half-life changes, what is the new half-life? Dia kata if the original concentration. Okay. So since this is a zero order reaction, half-life tu is dependent on the concentration lah. Half-life memang dependent, cuma dia punya rate law yang independent. Half-life dia dependent. Tengok ni. Dia punya formula half-life untuk zero order. Depend kan dekat dia punya concentration of reactant tersebut kan. So in this instance, the half-life will be decreased when the original concentration is reduced to 1.0 molar. So the new half-life will be 80 seconds. Macam mana you tahu 80 second ni? How do you get this? By calculate balik. Okay, you calculate balik. T half kan equals to concentration of Nh3, in this case Nh3 lah. Initial bahagikan dengan 2K kan. So you masukkan lah. Kalau concentration initial of your Nh3 tu jadi 1.0. So 2 kalikan dengan rate constant yang baru, which is 6.25 ni. 6.25 times 10 to the power of negative 3 should be, you dapat 80 seconds lah half-life dia. Supposedly lah 80 seconds. So sekarang ni you nampak tak dia punya half-life to decrease bila dia reduce to 1.0 molar. Decrease kan kalau ikutkan original 120 second. Tapi kalau let's say you tukarkan, reducekan dia punya concentration, so half-life dia pun will be reduced. Okay. Alright, so next soalan nombor 8. The data listed in the table below were obtained from the following decomposition, which A akan dapat produk. Okay, and then by plotting an appropriate graph, show the reaction is a second order. Kalau reaction second order, okay, I hope that you buat graph, plot graph for second order. Okay, second order graph. Okay, kalau graph second order, macam mana graph second order? Tengok balik table Miss bagi tu. Macam mana second order? Kalau second order, you nak plot graph apa yang you nak kena plot ni? For sure lah graph integrated rate law, bukan graph half-life ya. This is graph integrated rate law. It is never half-life punya graph. So tengok balik dekat nota Miss tu. Kalau integrated rate law punya graph is gonna be a linear graph. Okay. Kena dapat linear graph and then your y-axis. Okay. Your y-axis mestilah 1 over concentration of A. So bila 1 over concentration of A, that means you punya unit tu akan jadi per molar. Okay. Versuskan dengan time. Time T kecil tau, bukan time T besar. Kalau T besar itu adalah temperature. Kalau T kecil itu adalah time. Okay. T kecil, and then in this case dia bagi minit, you buat je minit, you jangan ubah apa-apa. So I hope that you get a straight line graph macam ni. Bila you dapat straight line graph macam ni, that shows that it is a second order reaction. Okay, bila you dapat straight line macam ni, terbuktilah you dapat second order reaction. Okay, and please don't forget bila you nak lukis graph ni, jangan lupa letak title. Graph of 1 over concentration of A against time, macam tu. Okay, and I hope that you fully utilize your graph paper. Make sure you lukis graph tu yang bila straight line ni memenuhi ruang 3/4 daripada kertas graph kamu. Okay, and next determine the rate constant. Kalau you tengok dekat table yang Miss bagi tu, kalau you nak tahu rate constant, you kena cari dia punya gradient. Okay, carilah gradient dia, cari yang the highest point, tolakkan dengan lowest point. Okay, kiranya gradient dia y2 minus y1 overkan dengan x2 minus x1. Okay, so since y ni unit dia ialah molar, x unit dia minute, so I assume that your rate constant ni K should be equals to molar per minute lah. Gradient ni actually you boleh je nak buat ni as a wayang. Gradient tu make sure kena ada 1, 2, 3, 4, more than 4 kotak lah ni, 1, 2, 3, 4, 5, more than 4 kotak. Tapi kalau nak calculation ngam, you ambil je yang highest point this one, lowest point this one. Okay, yang ni jangan ambil A yang concentration A macam ni pula, sebab you nak kena prove this is a second order punya graph. So you kena dah buat 1 over A. Okay, you kena buat another table di mana you buat 1 over concentration of A, unit ialah per molar. Okay, so you kira lah masing-masing berapa. Alright, and then you ambil lah nilai y1 dengan x1 you ialah yang paling rendah ni, which is 1 over A yang for this one and this one. For the x1, untuk nilai y2 dengan x2 you ambil yang this one, yang paling highest. Okay, alright, and then next ialah determine the half-life. Okay, if concentration initial ialah 1.00 molar, so nak determine half-life since that this is actually a second order. Okay, so apakah half-life second order? Itu you kena hafal. Okay, sorry. Alright, so let's look at here. And this one you janganlah plot macam ni Miss nak kamu plot betul-betul atas kertas graph, please. Okay, 1 over concentration of A ni, apakah unit dia? Unit tu you kena letak. Unit dia ialah per molar. Ni bukan T besar tau. Ni supposedly T kecil. Sebab minute time kan. Kalau T besar ialah itu temperature pula. So this one ialah minute. Okay. Saya nak you plot atas kertas graph, and please don't forget to put the title here. Title dia apa? Graph of 1 over concentration of reactant A against time. Okay. So suppose you akan dapat straight line begini. That means it's a second order reaction. Okay. Alright. Ni apa T besar ni? T kecil. So next ialah untuk cari rate constant, you boleh cari melalui slope. Slope tu apa? Slope tu gradient lah ya. Okay, so slope ni ialah gradient. So boleh cari melalui gradient. Gradient di mana y2 minus y1 bagikan dengan x2 minus x1. Okay, and bila you dah dapat gradient dia, ni unit dia. Kan betul Miss cakap per molar per minute. Okay. Sebab second order kan. So it's actually per molar per minute. Sorry guys. Yang ni pembetulan kat sini. Sebab this one supposed per molar kan. Sebab you punya Y ialah 1 over concentration of A. So per molar. So it should be per molar per minute. Okay, so next. Half time. Half time, you ingatlah half time untuk second order, which is half life dia is equals to 1 over K concentration of initial. Tapi dia kata if concentration initial dia 1 molar berapa? So you masukkan sajalah 1 molar. Rate constant ni something that you dah dapat daripada graph. Okay, so please lah buat gradient, lukislah gradient. Okay, untuk wayang je. Tapi kira ni you ambil je lah kira daripada lowest point dengan highest point, lowest point dengan highest point. Okay. Okay, and then next, I think that's all untuk chapter 1.1. Okay, for the next question is gonna be for chapter 1.2. So I think that's all. I'm gonna stop sharing. Okay. So, okay lah, itu je for 1.1.